Hey everyone, today we have got an interesting 3D scan that a viewer sent in, and we will be using it to explore some reverse engineering techniques together. The viewer didn't mention what this part is or what it's used for, but I can make out a faint logo, and after looking it up online, I'm pretty sure it's a 2-bit holder from VLAR. This 3D scan was captured with the original Creality Raptor in laser mode. That setup delivers a result solid enough for professional level reverse engineering, and you will see exactly how in this demonstration. This is the cover video I shot with the original Raptor, the one I bought myself about 2 years ago. This blue model was reverse engineered from the Raptor scan. Even though it's not the newest laser scanner, it still produces a dataset that is generally usable. The precision is impressive. When you mirror parts from left to right, they line up at a micron level accuracy. I have received several scan datasets from viewers using the new real point models, the Metro Vibe and the Inspire 2, but honestly, the results don't come close to the precision of the 2-year-old Raptor. The river point scans usually carry about 0.3 to 0.4 millimeter of error, which makes reverse engineering really tough. If you are just starting out and working with a limited budget, I would definitely recommend the original Raptor. If you can find one at a good price, it makes learning reverse engineering a whole lot easier. At first I tried modeling this part in FreeCAD, but I quickly realized it's too complex and most of you wouldn't be able to follow the entire process there. So for this tutorial, I'll be using BricsCAD instead. It offers faster plane creation, a stronger fillet tool, and the ability to align point clouds to an axis or plane with zero deviation, all of which we will need to get this part modeled correctly. Here is the modeling plan. I'll be building this part using 3 separate bodies. Part A will be the mirror sections, so the first step is to locate the exact mirror plane, and I will show you how to do that in the tutorial. The center body will be created using the loft command and then shaped with a simple extrude cut. 3 of the round corners will be built using the fillet command, but the one on the lower right has to be created with surface patching instead. Body A is a bit tricky since it's not flat. I will model it by cutting along curves on 2 different planes. The center body is also built from a different plane. I will model it by snapping a plane directly onto the point cloud and then performing an extrude cut. That's why this step really needs to be done in BricsCAD or Autodesk Inventor. The scan data was provided in STL format, so I will first convert it into a point cloud using Cloud Compare. I have saved the file in LAS format, and the download link is in the description so you can follow along. Now in BricsCAD, the first step is to import the point cloud. I have included a link to the BricsCAD free trial in the description so you can follow along. What I'm doing here is creating an axis between these 2 arcs, then aligning that axis to a vertical line using the align command. This alignment approach works only with point clouds in AutoCAD and BricsCAD. Next, I will move the point cloud to the origin using the center of the axis as the reference point. Next, I will locate the center of the point cloud along its length and move it to the origin point. Next, I will start modeling the end portion of the part by approximating its sketch plane. I will refine it later with a precise cut. Now you can see the quality of the scan data from the Raptor. I have never seen a remote point scan come close to this level. This is my professional and honest opinion, and neither Creality nor BricsCAD has ever paid me to make these videos. Okay, now I'm making the first curve cut on the end portion. Since the geometry is curved on both planes, I will need to make 2 cuts. The curve has only a very slight change and it's almost flat, so there is no need to model this using surface modeling. When the geometry isn't too complex, you can build it simply by cutting the solid from 2 planes. And here is the tricky part. I make the cut by snapping a plane directly onto the point cloud. With 3D snap turned on, you can quickly create a plane from the point cloud using the 3-point UCS. Here again, you can see how easy it is to trace the Raptor scan data. And remember, you need to join the lines first before you can run the Extrude command. Since we have precisely moved the point cloud center to the origin, I can simply mirror the end portion to the other side and it will land exactly where it should. Next, I will extract the edges from the solid and move them to the center to create the loft sketch profile. This profile needs to span the full height of the part. Here I'm using the loft command without guide rails to create this part. The bottom arc is shorter, so I will cut it out using the push-pull command. Mirror the loft section to the opposite side, then union them together. Before cutting this profile, you should first create the taper plane along the side of the lofted body. I must have forgotten to record that part of the process. Simply use the 3-point UCS to snap onto the point cloud and create a cutting profile on both sides of the lofted body. Next, I will create the round corners using the fillet command. Just pull them out until they match the profile of the point cloud. There is an issue with this corner. I can only apply a 2mm fillet, which is too small. So instead, I will create 3D lines and splines to frame the patch surface. This should be your last resort when other methods fail. Surface patching can be used to create any shape and then turn into a solid, but the creation time is longer compared to other approaches. Luckily, we only need to do this for one corner. In BricsCAD, it's best to frame the surface patch as a square. This produces a more reliable surface profile compared to using rectangular frame. Here I'm creating the profile to cut the bottom pocket. There is another one on the opposite side, but with a different shape. I have completed many reverse engineering projects using a Raptor scan data provided by customers. No issue so far. It's proven very suitable for reverse engineering. Since the Raptor doesn't have a single line laser mode to scan depth, I can't determine exactly how deep this pocket should go, so I will have to estimate. Alternatively, you can measure it manually with a caliper. Now I'm creating the holder profiles for the 2 bits. The sketching performance in BricsCAD is excellent. You won't run into issue with unclosed loops, and if you do, they are very easy to locate and fix. When you are doing reverse engineering professionally, project time has to be kept to a minimum. If you run into a problem, you need to fix it quickly. For example, when I couldn't fillet one of the corners, I had the option to create it using surface patching instead. Now I'm modeling an imprint from a box by drawing sketches onto planes and cutting them into shape. This direct modeling approach is one of the advantages you will find in BricsCAD. The point cloud we are working with contains 1.5 million points. I have pushed BricsCAD up to 150 million points before, and it still runs fluidly. That means you don't need to decimate the 3D scan resolution to work with it. You will retain all the detail and accuracy. For the final step, I will create a text imprint. I simply type in the text and then use an extrude cut to apply it. This CAD model is only 0.6 megabyte. As I have mentioned before, CAD models are visualized by executing commands, which give them infinite resolution. The blue model you saw earlier in the video was converted from this CAD file into 7 million polygons, and that version takes up 500 megabytes. Here is the final result in the render scene. This polygon model was converted from the CAD file, and you can set the resolution to any level your computer can handle. That makes CAD format the most valuable form of 3D file. It's the original source of the design. You can generate a gigabyte size mesh model from a CAD file that's only 0.6 megabyte. Here's the end of the tutorial. Thanks you guys for watching. I'll see you in the next video.